The history and evolution of cloud computing. Cloud computing is an evolution of technology over time. The concept of cloud computing dates to the 1950s, when large-scale mainframes with high-volume processing power became available. The practice of time-sharing, or resource pooling, evolved to make efficient use of the computing power of mainframes. Using dumb terminals, whose sole purpose was facilitating access to the mainframes, multiple users could access the same data storage layer and CPU power from any terminal. In the 1970s, with the release of an operating system called Virtual Machine, VM, it became possible for mainframes to have multiple virtual systems, or virtual machines, on a single physical node. The virtual machine operating system evolved from the 1950s application of shared access of a mainframe by allowing multiple distinct computing environments to exist on the same physical hardware. Each virtual machine hosted guest operating systems that behaved like they had their own memory, CPU, and hard drives, even though these were shared resources. Virtualization thus became a technological driver and a massive catalyst for some of the most significant evolutions in communications and computing. Even 20 years ago, physical hardware was quite expensive. With the internet becoming more accessible and the need to make hardware costs more viable, servers were virtualized into shared hosting environments, virtual private servers, and virtual dedicated servers, using the same functionality the virtual machine operating system provided. So, for example, if a company needed an X number of physical systems to run their applications, they could split one physical node into multiple virtual systems. A hypervisor is a small software layer that enables multiple operating systems to run alongside each other, sharing the same physical computing resources. A hypervisor also separates the virtual machines logically, assigning each slice of the underlying computing power, memory, and storage, preventing the virtual machines from interfering with each other. So, if, for example, one operating system suffers a crash or a security compromise, the others can keep working. As technologies and hypervisors improved and could share and deliver resources reliably, some companies decided to make the cloud's benefits accessible to users. These users did not have an abundance of physical servers to create their cloud computing infrastructure. Since the servers were already online, spinning up a new instance was instantaneous. Users could now order cloud resources from a larger pool of available resources and pay for them on a per-use basis, also known as pay-as-you-go. This pay-as-you-go, or utility computing model, became one of the key drivers behind cloud computing's launching. The pay-per-use model allowed companies and even individual developers to pay for the computing resources as and when they use them, just like units of electricity. This allowed them to switch to a more cash flow-friendly OpEx model from a CapEx model. This model appealed to all sizes of companies, those who had little or no hardware, and even those that had lots of hardware, because now, instead of making substantial capital expenditures in hardware, they could pay for compute resources as and when needed. It also allowed them to scale their workloads during usage peaks and scale down when usage subsided. And this gave rise to modern-day cloud computing. Every organization's transformation journey is unique, and therefore every organization's cloud adoption strategy is also unique to them. Agility, flexibility, and competitiveness are key drivers for moving to the cloud, provided it is done without creating business disruption or issues related to security, compliance, and performance. Let's look at some key considerations that organizations can use as a guide while working through their cloud strategy. The first consideration is infrastructure and workloads. The cost of building and operating data centers can become astronomical. On the other hand, low initial costs and pay-as-you-go attributes of cloud computing can add up to significant cost savings. Also, a point to consider is that not all workloads may be ready for the cloud as is. The second consideration is around software as a service and development platforms. Organizations need to consider if paying for application access is a more viable option than purchasing off-the-shelf software and subsequently investing in upgrades. Organizations need to consider speed and productivity, what it means for them to get a new application up and running in X hours on the cloud versus a couple of weeks, even months on traditional platforms, and the person-hour cost efficiencies they gain from using cloud dashboards, real-time statistics, and active analytics. Let's look at some of the benefits of cloud adoption, categorized broadly into flexibility, efficiency, and strategic value. Cloud gives us flexibility. Users can scale back or scale up services to fit their needs, customize applications, and access cloud services from anywhere with an internet connection. Cloud infrastructure scales on demand to support fluctuating workloads. Organizations can determine their level of control with as-a-service options. Users can select from a menu of pre-built tools and features to build a solution that fits their specific needs. And options like encryption and API keys help keep data secure. Cloud also brings great efficiency. Enterprise users can get applications to market quickly without worrying about underlying infrastructure costs or its maintenance. Cloud-based applications and data are accessible from virtually any internet-connected device. Hardware failures do not result in data loss because of backups maintained on the network. Cloud computing uses remote resources, saving organizations the cost of servers and other equipment and paying on use basis. Cloud services give enterprises a competitive advantage by providing the most innovative technologies available while managing the underlying infrastructure, thus enabling organizations to focus on their priorities. While cloud brings great opportunity, it also introduces challenges for business leaders and IT departments. Some of these perceived risks include data security associated with loss or unavailability of data causing business disruption, governance and sovereignty issues, legal, regulatory, and compliance issues, lack of standardization in how the constantly evolving technologies integrate and interoperate, choosing the right deployment and service models to serve specific needs, partnering with the right cloud service providers, concerns related to business continuity and disaster recovery. Organizations can no longer think of cloud adoption as something that is to be looked at in the future. With the right cloud adoption strategies, technologies, services, and service providers, these risks can be mitigated. In the next video, we're going to look at some of the key cloud service providers of our time and the services they offer.